comparison of stage and histology-specific CT sensitivity in the Nelson trial and the NLST.
Thank you. It's an honor to present here on this new analysis of data from the Nelson trial, for whom I should, of course, thank my colleagues and as well anyone who worked on the Nelson trial to make this analysis possible. I'll be presenting a comparison of CT sensitivity, that is the detectability of lung cancer, in the Nelson trial compared to a previous analysis we did of the CT sensitivity in the NLST. I don't have any relevant financial disclosures, but we owe a debt, of course, to Son and Wei, who granted the Nelson study. There have been two major trials of CT screening for lung cancer that were powered to demonstrate a mortality reduction specific to lung cancer. There have been others, of course, but these were large enough to demonstrate this difference. Both trials employed CT screening, but they also had particular differences. Namely, of course, the NLST was larger. It was in a US population. The Nelson trial was in a Dutch-Belgian population. And then the NLST had 3 annual screens, whereas the Nelson trial had screens increasing in interval. 1 year, 1.5 years, 2 years, 2.5 years, for a total of 4 screens. Also, the study population differed slightly. There were different smoking eligibility requirements, as well as a different proportion of males and females between the 2 trials. And lastly, which we consider a key difference as well, is that they differed in the management of pulmonary nodules as found on the CT screen. Nelson employed a volumetric nodule management follow-up protocol to refer people to a follow-up screen, whereas the NLST looked at the diameter of the nodule in deciding a follow-up procedure. And this decision between which type of protocol to use is still an active discussion. If we look at the lung rights guidelines in the US, these are still largely diameter-based, whereas the British Thoracic Society and many early implementation studies in the European setting recommend a volume-based Nelson-like protocol. We also see differences in outcomes between the 2 studies. The NLST demonstrated a 20% mortality reduction in lung cancer-specific mortality, whereas the Nelson trial demonstrated a 24% lung cancer mortality reduction among the male participants, and although not statistically significant, mortality reduction was even larger among women. Additionally, the stage shift in the NLST was already very good, where we saw screen-detected lung cancers largely around stage 1A, 1B, but there were also still quite a few 3B, 4 cancers. In the Nelson trial, this was further improved, where we saw over 70% stage 1A, 1B cancers, with a lower proportion 3B to 4 cancers. So taking into account the differences in the trial setup, the trial population, as well as the nodule management protocol, and looking at these differences in outcomes, we were interested to know how can we assign this difference in outcome to each of these differences in the trial setup, which pertains to this research question. To which extent are the more favorable stage shift and larger efficacy of the Nelson trial attributable to potential differences in CT sensitivity? It could be that it's the number of screens, it could be that it's the screening interval, or it could be that we were better able to detect the lung cancers using a volume-based nodule management protocol. To make this assessment, we use a microsimulation model, which is the Miscan lung model. It's been used for other studies before. We have done some cost-effectiveness analyses with it, and it has also informed the 2014 and 2021 US BSTF guidelines for screening eligibility. The model works on a participant level. We look at the characteristics of the participant, their smoking history, their age, at the time of entering the trial, their gender, and we make individual level predictions of, do we suspect that this person is likely to have a lung cancer at the moment of their screen? And if they have a lung cancer, we think it may be in stage 1A, 1B, further on. We make many repeated estimates to get an aggregate indication of what we suspect the number of detectable cancers is at each screening event. And we have done this before for the NLST. What we then do is we compare what we expect the number of detectable cancers should be to what we actually detect. And this gives us an estimate of the sensitivity, not just for the CT sensitivity, for the CT scan as a whole, but by stage and histology as well. If we expect lots of 1A cancers to be prevalent, but we only detect a few, that suggests a small sensitivity. Rather, if the detected cancers is very close to our estimate, it suggests a very high sensitivity. And we can do this also using the histology distribution that we know from incidence data to get it specific to the histology of the cancer. And we can also, in the simulation, make sure that the timing of the screens for each participant, which are then aggregated to a trial level, is particular to the trial. So for our analysis of the NLST data, we simulated 3 annual screens. For our analysis of the Nelson data, we do screens at the interval particular to Nelson, and we also, of course, do 4 screens to represent the Nelson trial. And this allows us to control for all those characteristics that were mentioned before. Different trial setup, as well as the individual participant characteristics. What we then find is the following. In the light blue, you see our estimates that we had before from the NLST. In the dark blue, you see our Nelson estimates. On the y-axis is the estimated CT sensitivity by stage, as well as by the 2 primary histologies of adenocarcinoma and squamous cell carcinoma. And we find that, particularly for stage 1A adenocarcinoma, the sensitivity was already quite good. We are generally able to detect the adenocarcinomas quite well, but it's further improved from 57% up to 73%. For squamous, there's also some improvement for stage 1A. We did not find a difference for stage 1B, but we see stage 2 a very large improvement in our rate of detectability. And this extends also to the larger stages, but of course, for screening, we're interested mostly in those 1A to 2 lung cancers. Can we detect those so that we can achieve a favorable stage shift and potentially help someone achieve a better survival outcome? So what I would like to leave you with today is this. If we perform simulation modeling, we find a higher sensitivity in the Nelson trial for early stage adenocarcinoma particularly, as well as stage 2 squamous cell carcinoma with sensitivities as high as 73% for detecting a stage 1A adenocarcinoma. And we find that this is able to explain the stage shift and efficacy of the Nelson trial. We did not find the timing of the screens, nor the number of the screens, nor the study population in itself to be able to explain the difference we saw in the stage shift in the Nelson trial. For that, we needed new estimates of the CT sensitivity. And this indicates that the volume-based nodule management, which we already know to have a lower follow-up rate, so that it's associated with less unnecessary biopsies and burden of increased follow-up. It may also be associated with higher ability to detect these early-stage lung cancers, and therefore we're seeing early-stage implementation studies in Europe. The US is already recommending screening as well. It may improve the lung cancer mortality reduction in population screening levels. That's it. Thank you very much.